Hello, and thank you for joining me today for our discussion on machines. So first, we need to figure out what a machine is. So with this, machines um, are things. So it takes much less effort to lift a car with a jack than by hand. So you ever get a flat tire, way easier to lift a car with a jack than by hand. Both require the same amount of work because you're still moving the same object over the same distance. So the same amount of work being done. But jacks make it easier by allowing you to apply less force at any given moment. So it's easier because you allow less force. Machines are devices that do work by either changing the size of an input force, the direction of the input force, or both. So either changing the magnitude of the force or the direction of the force. For example, pulling down instead of up is sometimes easier. But your machines redistribute the work and can change the direction, and that's kind of their function. They can also increase the force, so they can make the force greater by decreasing the distance over which the force is applied. And this is called multiplying the force, which we're going to look at here today. The first machine we're going to talk about is a ramp, or an inclined plane. So ramps, for example, make work easier by multiplying the force that is applied. So we have made a longer distance to make, but allowed the force to be much less. So scientists and engineers use numbers. Use a number that describes how much the force is multiplied. This is called the mechanical advantage. So this is what we're going to calculate on these different machines. It's called the mechanical advantage. This is the ratio between the output force and the input force, or the input distance and the output distance. So you need both of these equations here. So MA is mechanical advantage is equal to force out divided by force in, or it is also equal to distance in divided by distance out. And we'll look at this, we'll show you kind of what this means here in a second. But machines with a mechanical advantage greater than 1, if your mechanical advantage is greater than 1, they multiply the input force. If they have a mechanical advantage of less than 1, only increase the distance and speed. So they don't change the force, they just change the distance. Okay, so let's look at this. So different forces do the same amount of work. So here's the diagram. This guy can lift a box that has a force of 225 newtons. And he can lift that box 1 meter. So he can do 225 joules of work by lifting this box 1 meter. Okay, so that can be done, absolutely. Or he can raise this box up 1 meter by pushing it up a ramp. And in this case, the ramp is 3 meters long. So instead, he exerts 75 newtons over 3 meters because the 3 meter ramp would change his distance. So his force, total work has to be 225 divided by my 3 meters, which is going to give you a force of 75 newtons. So work equals force times distance. The work has to be the same. My 225 has to stay the same. But I can have 3 meters as my distance, and I can take that times F. I can divide both sides by 3 meters. And that's where we get F equals 75 newtons. So he decreased the amount of force he needed, but increased the distance over which it traveled. So both scenarios had the same amount of work, but the amount of force needed to lift the box is less with the ramp because he did it for a longer period of time. So you can lift it straight up with 225 newtons, or you can push it 75 newtons for 3 meters. Either way, we get the same amount of work. All right, let's put this into practice. I'll do the first one with you. I'll give you the second two to try on your own. So first one says, calculate the mechanical advantage of a ramp that is 5 meters long and 1 meter high. So this is going to be my input distance. So because I'm pushing it 5 meters, I know that my distance in is going to be 5 meters, because that's what I put into moving this box, or traveling this ramp. It also went up 1 meter, so my output distance, the height that I'm going to travel by going those 5 meters, is only 1.5 meters vertically. Okay, so my mechanical advantage, if you think back, we look at our equations, I can use distance in divided by distance out. So I'm going to take 5.0 meters divided by 1.5 meters. And when I do that, I get an answer of 3.3, and it's repeating, but we'll just call it 3.3 because I have two sig figs here and two significant figures here. We'll call it 3.3, make a better 3 there. There is no unit on mechanical advantage, it's a multiplier. So 3.3 is going to be my answer. I'll let you try the next two. So the next one, find the mechanical advantage of a ramp that's 6 meters long and 1.5 meters high. And the last one, Alex pulls on the handle of a claw hammer with a force of 15 newtons. If the hammer has a mechanical advantage of 5.2, how much force is exerted on the nail in the claw? So you have to figure out your input forces and output forces for this bottom one. Give those a shot, pause this video, and then when you resume it, I'll give you the answers on the next slide. So these are your answers. So again, on this one, you would have taken input distance divided by output distance. So D in over D out. You get 6.0 divided by 1.5, which equals 4. And the bottom one, we know that that was equal to mechanical advantage. We know that mechanical advantage is equal to your force out divided by your force in. Okay, so he pulls, Alex is pulling on the handle with a force of 15 newtons. That's his force that he's putting into the hammer. I know that my mechanical advantage is 5.2. I don't know what this F out is, but I know that I put in 15 newtons. So again, to move the 15, we take both sides times 15 newtons. And if you take 5.2 times 15 newtons, you should get 78 newtons there. That is mechanical advantage. I would like you to do a couple of these review questions. So I would like you to first define work and power. Tell me how they're related. I would like you to compare a long ramp and a short ramp. Tell me which one of those has a greater mechanical advantage. And you can reference your previous questions that you've done. And then I would like you to answer these 4 math questions. 5, 6, 7. Do both A and B, and 8. When you get those done, you can share them with me, and that'll give me a chance to see how you're doing. But thank you for watching this video, and I look forward to working with you as we talk through work, power, and machines.